Hi everyone, welcome to the Earth Science Regents Review podcast series created by Homix Middle School Earth Science Department. Today we're going to be talking about igneous rocks. Now, igneous rocks are interesting because they're found in areas of high volcanism. So you're going to find areas of a lot of molten rock. Now the molten rock beneath the surface is magma, the molten rock at the surface is lava. So when that molten rock begins to cool off, it's going to start to crystallize and you're going to start to get mineral crystals. And eventually you get enough mineral crystals, it's going to solidify into solid rock. Now what's going to happen here is you want to look for that intergrown or interlocking crystal structure within the rock. Sometimes they're big, sometimes they're small. We'll talk to you about the difference between them in a second. Now those igneous rocks are organized by texture. When you talk about texture, you talk about crystal size or grain size. Sometimes very big, sometimes very small. That's all dependent upon the cooling time of lava or magma. And we'll talk to you about when you get big crystals and when you get small crystals. Now, igneous characteristics are important here, so you need to make sure you understand the differences between the two different characteristics of rocks. So you either have a felsic rock, which is made up of aluminum and silicon, okay, in regards to its elements, has a low density, light color, and primarily made of light-colored plagioclase and potassium feldspar and quartz. You also have what are called mafic rocks, which are made up of the elements iron and magnesium, which gives them a much higher density, a much darker color in regards to the dark minerals that make them up: pyroxene, olivine, biotite, and amphibole. So what's important here is to understand that certain rocks form at certain parts of the Earth. If they form inside the Earth, they're called intrusive rocks. You tend to get very, very slow cooling in magma because it takes a long time for the magma to cool off. In some cases, upwards of a few million years. Well, the slower the cooling of magma, the larger the crystal forms. So these crystals are going to give you a texture of either coarse or very coarse minerals. Now, very coarse minerals are going to be bigger than 10 millimeters in diameter. Your coarse minerals tend to be somewhere between 1 to 10 millimeters in diameter. Let me show you some pictures of these. So the only very coarse rock you have in your reference table is pegmatite. Okay? Massive crystals, light in color, felsic. You have a couple coarse grain rocks. Granite and gabbro are the two most common. Granite is light in color, tends to be felsic in nature. Gabbro tends to be dark in color, mafic in nature. Again, coarse grain rocks, you do not need a magnifying glass to identify the crystals within them. Staying on the mafic side, you have peridotite, which is made up of pyroxene and olivine, and dunite, which is essentially monomineralic, is made up of olivine as well. So again, those are going to be some mafic rocks, coarse grain. You also have one rock that kind of falls right in the middle that's coarse grain, and that's diorite. It's neither felsic nor mafic, kind of falls right in the middle. Has an average density, has an average composition, has an average color. That leads us to our extrusive rocks. These are going to be the rocks that form at the surface or on the exterior of the Earth. Extremely fast cooling of lava. In some cases, the cooling is so instant that you don't get any crystals at all. So the fast cooling is going to give you small crystals or no crystals at all. Now you have three textures that you need to identify. Fine, which is smaller than a millimeter. Glassy, no crystals at all. And then vesicular just means you have trapped gas pockets within the rock. These rocks, you do need a magnifying glass to see the crystals. So let me just show you here. You have rhyolite and you have basalt. They're both fine grain rocks. Light in color is rhyolite, felsic in nature. Basalt is dark in color, mafic in nature. From there, we'll move into our vesicular rocks. Pumice is light in color, and it's going to be felsic. Scoria or vesicular basalt is darker in color and a little bit more mafic. We also have a rock called obsidian. Obsidian is actually dark in color to the look, but it's on the felsic side of your reference table. Okay? Even though it's dark in color, if you take this rock and you cut it into real thin sections, it's literally transparent. So it's generally light in color, but because light can't be transmitted through it, it appears black to us. Okay, so obsidian actually is a felsic rock. Now you do have a rock called diabase. That could either be intrusive or extrusive based upon its environment of formation. You do have one rock that kind of falls right in the middle. That's andesite. This is the fine grain rock that kind of has an average composition, average color, and average density. Okay, please, please, please make sure you understand how to read page 6 in the reference table. This is your Igneous Rock chart. Okay, that's it for now. Thanks so much.